An astronomer may have found proof of a proposed Planet 9 near the edge of the solar system while reviewing data gathered in the 1980s. Since the idea that a planet much further from the Sun might exist was originally put forth in 1846, following the discovery of Neptune, the planet has been the subject of speculative research. This enormous frozen planet, which many scientists speculate may exist beyond even the furthest body of the solar system, is thought to be buried by the Kuiper Belt's icy comets. Even while it appears to have an impact on these bodies, some of the smaller worlds in the solar system, and even the axial tilt of the Sun, Planet 9 is still frustratingly elusive. As a result, some astronomers are now searching diligently for Planet 9, while others have chosen to ignore its possibility. Before Pluto was downgraded to a dwarf planet, Michael Rowan Robinson had started the hunt for what would have been the solar system's 10th planet at the time. Since nothing was discovered during this investigation, Rowan Robinson concluded that Planet 9 did not exist in 1991. This changed after Rowan Robinson re-examined the historical data he had first looked at in the 1980s, with an eye toward new discoveries regarding planetary systems. This exposed three infrared sources that, according to Rowan Robinson, might represent the long-theorized world. The discovery made by Rowan Robinson may revive the discussion surrounding Planet 9, bringing it back into the spotlight once more as the solar system's most enigmatic entity. The Kuiper Belt, which is beyond Neptune and is thought to include Planet 9, is made up of frozen bodies ranging in size from big boulders to something with a diameter larger than 1,000 miles. These objects are remnants of the early solar system's formation and were never absorbed into the planets. The majority of the Kuiper Belt's objects, which also includes the dwarf planet Pluto, have incredibly distant orbits that take them far from the Sun. Many of these orbits appear to be tilted at the same angle and grouped within the same solar system quadrant. In 2016, Battingen said, "Although we were initially quite skeptic that this planet could exist, as we continue to investigate its orbit and what it would mean for the outer solar system, we become increasingly convinced that it is out there." Brown and Battingen developed a mathematical model that may suggest the existence of some large, unseen body that is stretching out and tilting these bodies' orbits. There is convincing evidence that the solar system's planetary count is incorrect for the first time in more than 150 years. Could an undiscovered Planet 9 be extending the orbits of these objects? Amir Siraj, a theoretical astronomer at Harvard University, claimed that this evidence has always been the strongest for Planet 9. According to Siraj in a statement to Newsweek, Planet 9 appears to be a potentially plausible explanation for the observed clustering of some objects beyond the orbit of Neptune. If Planet 9's existence is confirmed by a direct electromagnetic search, it will be the solar system's first discovery of a new planet in 200 years. Siraj explains that Planet 9 might be so hard to find because it would be so black that it would be only seen in the visible portion of the electromagnetic spectrum with the greatest powerful telescopes. The planet could be anywhere in the sky, therefore a thorough search would be required to locate it. Samantha Lawler, an assistant professor of astronomy at the University of Regina, spoke about the clustering objects in the Kuiper Belt, which are currently the best source of evidence supporting the statement that at least two teams are conducting focused searches. This unknown planet is expected to be quite dim and far away, so they will need to use rather large telescopes from top-notch observation locations, according to Newsweek. No new planet has been discovered despite an intensive search. Lawler is a member of the OSS-OS team that over the course of 5 years doubled the number of Kuiper Belt objects cataloged by astronomers by finding over 800 new objects with the Canada-France-Hawaii telescope. Lawler noted that the initial clustering pattern that was used to infer the existence of Planet 9 weakens and weakens as the orbits of these far-off Kuiper Belt objects are plotted. Researchers have found more Kuiper Belt objects, but the clumping that suggested the possibility of Planet 9 appears to have vanished. They have found 300 more Kuiper Belt objects using data from the Dark Energy Survey in addition to the work of Lawler's OSS-OS team. Additionally, this revealed none of the orbital clustering linked to Planet 9 data. She draws attention to the fact that this indicates that years of diligently looking for Planet 9 have not shown any indication of a planet near the boundary of the solar system. Lawler added, "My own research has shown that the evidence really isn't there to support this particular theory. So should we stop looking for Planet 9? Even if there hasn't been a planet discovered at the frontier of the solar system yet, according to Lawler, the search for Planet 9 isn't wholly ineffective. The notion of Planet 9 has generated a large amount of research into the Kuiper Belt, and many astronomers were very eager to try to test this theory in many different ways. It's such a great concept. There are a lot of fantastic discoveries in the outer solar system that are just waiting to be uncovered. So even while I don't think we should be looking for Planet 9 directly because the evidence isn't there, I think it's a great use of telescope resources. Another idea put out by Siraj would have Planet 9 not even being a planet. He has started researching the idea that this object in the Kuiper Belt at the edge of the solar system might be a grapefruit-sized black hole with a mass 5 to 10 times that of the Earth. He acknowledges how remote the possibility of this is. According to Siraj, Planet 9 is most likely a planet, not a black hole, and there is no clear evidence that black holes with masses smaller than roughly that of the Sun exist. But if it were true, finding a black hole outside of our solar system would demonstrate the existence of primordial black holes and act as a laboratory for basic physics. Siraj calculated that if Planet 9 were a black hole, comets from the Kuiper Belt would produce electromagnetic flares when they passed by it. He worked on this alongside Harvard's theoretical physicist Avi Loeb. Recently, the two wrote a study on the subject. According to Siraj, the Vera C. Rubin Observatory's Legacy Survey of Space and Time, which will go online soon, will be the ideal tool for determining whether a black hole exists in the outer solar system. In other words, if Siraj is right, as Lawler contends, then the quest for Planet 9 may ultimately lead to something much more important to the advancement of science. Alright guys, that wraps up our video for today. If you enjoyed watching, please give us a thumbs up and hit the subscribe button for more.